All right, this is Practice 9, modeling with equations. This first illustration, car rental charges $30 every single day. So one day would be $30, 2 days would be 60, 3 days would be 90, and they also charge 15 cents every single mile that you drive on the car. Well, Helen rents the car for 2 days. Well, when you start setting this up, you know that there's 2 day, it's 2 day rental, and it's for $30 per day. So you automatically know that. Plus, it's 15 cents per mile. And again, we don't know how many miles. That's what we're trying to find. That's what the question says. So we're going to represent that as X. And we know the final bill comes to 108. So what we need to do is just simply solve this problem. So this is 60. And then we have 0.15, X equals 48. And then we're just going to take 48 divided by 0.15, and we're going to get 320. So Helen drove 320 miles on that 2 day rental. All right, so let's look at another illustration. So here, George invests $100,000 into 2 accounts. One makes 4.5%, and the other makes 6% interest. And then she ended up making $5,025 in total interest. So we're going to keep in mind that we're going to be using I equals PRT. We're going to use that formula several times. We're also going to just randomly pick. It doesn't really make a difference, but I'm going to say we're trying to find out how much she put into each account. So we're going to actually say the 6% is how much she invested. So X equals the amount of money, at 6%. So that's what X represents. So again, there's 2 accounts. If you want to say X and Y or something like that, you can. We just know that there are 2 accounts. So if we have the amount of money at 4.5%, I mean, you could use 4.5. You could use Y or something like that, but let's keep it defined as one variable. Again, you have $10,000, and we have 2 accounts, and we're going to put a certain amount over here, and we're going to put a certain amount over here. Well, if we know this is X amount, then this is obviously going to be 10,000 minus X. All right, so that's what we're going to use. Instead of using 2 different variables, we're going to say 10,000 minus X for that account. Now, following, I equals PRT, following that for this first account, the principal is, again, X times the rate, so 6% as a decimal, 0.06. And again, we're just finding it for that year, so that would be just be 1. So this would be 0.06 X. All right, and then same thing here, following this formula, this would be 10,000 minus X times 0.045 times 1. So we're basically this. All right, so that's the 2. We're trying to find the interest, and we know those 2 interests add together. So we're literally just going to take these 2 amounts, and we're going to add them together to be able to equal the 5,025. So all we're going to do is 0.06x, and then we're going to add that to 10,000 x. We're going to set that equal to 5,025. And then all we need to do is solve that equation to be able to get to the answer. So if you use the distributive property, I had to pause the video because I noticed I had made a typo. I didn't notice this is $100,000, and I was using 10,000 right here and right there. So I changed those values to 100,000 because the problem says 100,000, not 10,000. All right, so again, I used a distributed property and I got 0.06x plus 450 minus 0.045x. And then I'm going to start solving this. I have 0.015x because I combine my x's together. And this equals 525. And I noticed another mistake. I had to pause because something wasn't working out right, but this is actually 4,500 when I used the distributed property. All right. Originally, I had put 10,000, and that's where my mistake was. So this is 525, and then I'm just going to simply solve x. I'm going to end up getting 35,000. All right, so again, that's what we wanted to find is x is 35,000. So that's how much she put into this account. And notice the problem says how much did she put into each account. So then you just need to subtract the 100,000 from the 35,000 to find that amount, 65,000. All right, so let's look at the next one. A square garden has 3-foot walkway around it. So some of us, like myself, I have a garden in my backyard, and some of us may want to put a walkway around it just for easy access to it. And so you can see the diagram. The yellow is the garden, and I have a 3-foot walkway all the way around it. So if the area is 18,000 feet squared, including the walkway, so the entire thing is 18,000. What are the dimensions of just the garden? Well, we don't know the dimensions of the garden, so we're going to say that's x. And of course, it's a square, so we know that each dimension is x. So the length of each planet is x, so we know the area of the entire garden is x squared. But notice the distance from here to here is actually x plus 6, because you have the x, whatever that dimension is, and then you have 3 more feet and 3 more feet, so x plus 6. And of course, this side over here is x plus 6. So we're going to take x plus 6 times x plus 6, or times x plus 6, and we're going to multiply those together, and that will give us the area of the entire object, because we know that equals 18,000. And then we're going to take the square root of both sides. And then minus 6. So we got negative 6 plus or minus the square root of 18,000. And then you just plug that into your calculator, and you're going to get an approximate answer of 128 feet. So, and by the way, it says plus or minus, but remember, even though you're going to come up with a negative answer, you can't have a negative distance. So mathematically, you have plus or minus, but you have to throw that out because we're dealing with real life measurements, and it's positive. So the garden is approximately 128 feet by 128 feet. So literally 128 is 128. And again, that's approximate value, but it's very close to that. All right, let's look at this one. A 6-foot man wants to know the height of a 4-story building. So you can see my wonderful drawing. We have the sun up here, right here. There's the sun, and it's making a shadow on the building. It's 28 feet long from here to here. And the man is, the 6-foot tall man is right there, and it's the shadow of him. So again, the sun is coming down, and it's making a shadow that's 3.5 feet long. We know the man is 6 feet tall, and we know the height of the building. Actually, we don't know the height of the building, but we're going to label that as h. So we're just going to literally, because these are similar triangles, because they're coming from the same sun, and they're literally making 2 similar triangles, we're going to just set up the ratio h over 28. So notice we have the height over 28, right? The height of that, and that is the same thing as 6 over 3.5. And then all you have to do is solve that. So h equals 48. So that's how tall that building is. A 4-story building, 48 feet tall. All right, so Bill left his house. Last problem here, Bill left his house at 2 p.m. on a bike going 12 miles an hour. Mary left at 2:10, just 10 minutes afterwards, and she's trying to catch Bill. So notice that Bill is traveling 12 miles an hour, and Mary is going 16 miles an hour and trying to catch him. And I want to know, what time will Mary catch up to Bill? Well, we're going to use the formula D equals RT. Okay, and we know that what time will Mary catch up to Bill? That means they're going to travel the same. They left the house and they're going to end up at the same spot when Mary catches Bill. So the distances will literally equal one another. So we have the distance of Bill will equal the distance of Mary. So we literally know distance is RT. All right, so we know that the distances will equal one another, and so now we just need to fill in some information to be able to solve it. And we're trying to find out at what time will Mary catch up to Bill. And if you have to think about it, Bill left 10 minutes prior than Mary, and we know there's 60 minutes in an hour, so you literally have the time of Bill was literally the same time as Mary. So we have Bill and Mary, but notice Bill's time was, because he left 10 minutes earlier, he had a little bit of head start, and so he had 1/6 of an hour head start. Again, 10 minutes is 1/6 of an hour. So what we're going to do is a little substitution. So I substituted in the rates, the speed of Bill and the speed of Mary, and I also substituted in this right here, the time. I literally substituted that in for TB, the time of Bill, and then I just solved. I used the distributive property and solved. So notice the time that it took Mary to catch Bill was a half an hour, or 30 minutes. So I could also follow up with another question. If it's 30 minutes later, then obviously Mary left at 2:10 plus the 30 minutes. So they met up at 2:40 p.m. Mary caught up with Bill at 2:40 p.m.